I'm Anil Kumar sharing with you a very important concept relating speed, velocity, and acceleration. The question is the speed of an object moving in a straight line is absolute value of velocity, right? In speed, we don't have positive, negative. In velocity, we do have positive, negative. It's a vector. So, speed of an object is absolute value of velocity. That's a fact, right? Use the fact that square of absolute value of velocity is same as v square to show that the speed increases with respect to time when product of velocity and acceleration is greater than 0. So v is velocity, a is acceleration. Okay. Let's try to explore this. What we are saying here is that the speed, which is let's say s, is equal to absolute value of velocity, right? Velocity could be positive, negative. Speed is not positive, negative, right? If you're going 100 kilometers per hour north or south, it doesn't matter. Both are 100 kilometers per hour. So that is why we take absolute value of velocity to get speed. Now if I square both sides, what happens? So let us square both sides. We get square of speed is equals to absolute value of velocity square. Now this is positive. It is same as v square, right? So we can write this as speed square equals to v square. So all this is suggested in the question itself. What we need to prove is that the speed increases with respect to time when this condition happens. So increases with respect to time means, let's find derivative with respect to time. Do you understand? So we'll find derivative with respect to time, both sides. So let's do d dt of s square. That should be d dt of v square, right? So implicit derivation, we get 2s ds dt. Now s is not positioned here, I'm taking s as speed, okay? And then we get here, when you do this derivative, 2v dv dt, correct? Now we are interested in ds dt, that is increase with respect to time, speed increase with respect to time. So when you say speed increase with respect to time, it is this term here, right? Let me take it to the right side and explore further. So I'm rewriting the whole statement with ds dt equals to, so we'll divide by 2s. So we have 2v divided by 2s times dv dt, correct? 2 and 2 cancel. Now speed could be written as absolute value of velocity. So I could write this as v over absolute value of velocity times dv dt. What is dv dt? dv dt is acceleration, right? So we know acceleration a is dv dt. So we are going to substitute that here. So what we have got here is ds dt, rate of change of the speed, is in fact product of velocity and acceleration, right? Correct? So now absolute value of v is always positive, right? So we know that if I want ds dt to be increasing, that means greater than 0, that means increasing, v times a divided by absolute value of v should be greater than 0. Perfect. If I want ds dt to be increasing, that is ds dt should be greater than 0, that is increasing speed, correct? With respect to time, then v times a divided by magnitude of v is greater than 0. And that means that v times a is greater than 0. Why? Since absolute v is always greater than 0, right? So this is positive always, correct? It is always positive. So this is always true. So the condition we are looking for is this condition, that v times a should be greater than 0, correct? So that really helps us to find from the graph of velocity and acceleration, and also from the equation of velocity and acceleration, in which part is the object speeding and in which part is the object slowing down. Do you understand? So we can conclude from here that if v times a is greater than 0, it means speeding object. If it is less than 0, it means slowing down. So let me write down. If v times a is less than 0, that means, let me push this a bit, slowing down in speed. Is it okay? So that is a very important conclusion. And now in different examples from now onwards, we'll use this concept. Whenever we have to find speeding duration of an object, we'll see when the product of velocity and acceleration is positive. And if you want to find slowing down duration, find the interval where the product of velocity and acceleration is negative. I hope that helps. Thanks for watching. If you like, that's great. Feel free to share my videos and your suggestions. Thank you, and all the best.